Okay, we have about 1 minute left until our next session is going to start. So I'm going to stop this share to give those hosts an opportunity to get set up. Oh, and you're already set up. Great.
We're all ready to go. Yeah.
Mhm.
Well, at least it's daylight outside now.
Some of the things that have come through in the chat that are just a little bit more.
Yeah, hi everyone. While we're waiting, if you want to jump over to YouTube and either click on the link or copy the link that we pasted in the chat to check out a quick video of one of the puzzles we're going to be talking about. You can do that. You can also search for math problem solving critical thinking app, and that should bring up the 1-minute version of the video. And if you jump to 37 seconds in the space of about 5 to 10 seconds, you'll get a very quick understanding of the fundamental interaction. We'll get started here in just a minute or so.
Oh, I'm just noticing now that reopening the registration on Eventbrite, I'll try to make sure that that happens. Thank you for those of you who had colleagues. And yes, it's okay to share with colleagues the meeting URL.
Are we good?
Yes. I just wanted to answer a few of the things that were happening in the chat. But I'm good now.
All right, well, I think we'll get started here. Thank you all so much for taking some time out of your evening, your afternoon, or your morning. I think we have attendees from all over the world. We are so honored to be here with you and hope that we are able to add to your day and your practice in some small way. We'll get started with very, very brief intros, then share a little bit about what we're up to here, and then dive into the presentation. Keith, you want to reintroduce yourself real briefly?
Okay, so if you were up a few hours ago, I was the guy that did the introduction. I'm recently retired from Stanford.
Keith, you're muted.
Emeritus, sorry. I'm muted? No, I seem to be okay.
I can hear him okay.
Yeah, it's good at this end. Okay, so Keith Devlin, if you were
I'm not able to hear you.
If you were up for the keynote at the beginning, I gave the keynote and I was sort of wearing my Stanford hat then. Now I'm wearing my BrainQuake hat as the
can't
chief
hear you, Keith.
and one of the co-founders of BrainQuake.
I think the rest of us can hear. It may be, Randy, are you sure that your audio is on? Can you hear me? Okay, yeah, I think a lot of people are able to hear. So I think your audio might not be coming through, Randy.
There we are. Good. May have been a problem on my side. Keith, are you good?
I'm good, yeah. And it seems
fantastic. I think it was on my side. My apologies.
Okay, yeah.
My name is Randy Weiner. I'm the co-founder and CEO of BrainQuake. I taught for 5 years here in Oakland and in Madagascar. And around the same time that I co-founded BrainQuake, I also co-founded Oakland's only public Montessori school. And I've had the privilege of working with hundreds and hundreds of teachers in and around the Bay Area and the nation, both on math education, but on rapid iteration and innovation in particular. So today we're here to talk about breaking the symbol barrier. And we're going to use some of our work to illustrate the concept, but the point of our chat today isn't really about our content per se. We're going to use it to illustrate what the symbol barrier is and how one might break it. But the point is really to engage in a discussion and an analysis of what the symbol barrier is, why it is so damaging and disproportionately damaging, and how we might break it. And we don't have at the moment a product in the market that's optimized for schools, but we do think we have some thoughts about how you might be able to, in a very low or no tech way, leverage some of our work, or at least some of the thinking that we'll do here today in order to meet some of the challenges that you're all facing. We are extremely sensitive to the inequities that so many of you and your children are facing right now. And so we wanted to try to be as responsive to that as we possibly can. So just a quick reminder on the norms. We'll be using breakout rooms 3 different times. Please just remember to be respectful of the amount of time you use as you're speaking. Make sure that you provide space for others to chime in. Remember that your truth is one of many truths, and it's to be respected just as others' truths are. Speak to your own experience and let others speak to theirs, and then seek to be understood, not necessarily to be right. All right, and so we're going to go right into our first breakout room right now. And here's the prompt for all of you to think about. If you could change one thing about mathematics, what would it be and why? And so as Kara sends you into the breakout rooms, maybe select a facilitator, someone who can just keep an eye on time and try to ensure that all voices that want to be heard are heard. And then when we come back from the breakout room, feel free to share in chat any of the comments that you made or others made that really struck you. And while you're doing that, we're going to continue on with the presentation. So Kara, I think we're good to go into the breakout rooms.
Okay, I'm going to open all of the rooms right now. And remember, you can always leave your breakout room and come back and join the main session in the bottom right by pressing leave room. If any of you are left in this room and you would like to join a breakout room, so you can type a message to either me, Kara Carpenter, in the chat, or you can type a message to everyone in the chat, and I'll make sure that you get assigned to a breakout room.
Kara, maybe bring folks back in about a minute.
Okay, I'll press the close all rooms now, and then that would mean in 1 minute everyone's back here. Is that what you mean?
Yeah, let's wait another 30 seconds.
Okay, will do. Are you able to join the other, like sort of go back in and join the other meetings?
The breakout rooms?
Yeah.
I think I can. I wasn't planning on doing so.
You don't need to. I was just curious.
Yeah.
Scott was saying he had trouble with that earlier.
Oh, well, let's see. I'm happy to test. I know I was in a room and I left it.
Yeah.
It looks like I can go back into the room that you assigned me to.
Uh-huh.
That
Not seeing the other joins. This is different than our technical rehearsal. I think something may have happened because of the size of our meeting.
Sure.
But the co-hosts don't have as much ability as we thought they would.
It's all good. Definitely not needed. Yeah, why don't we pull them back in?
I'm going to close all of them so everyone's going to be back with us in 1 minute.
Yep.
Mm-hmm.
Okay, so I think folks are back in now.
Yep.
Great. So hopefully you had an opportunity to share some of your thoughts about this prompt. Like I said earlier, go ahead and share any of your comments or observations or things that you heard that intrigued you or stood out in the chat while we continue on here. So when we think about breaking the symbol barrier, this is one of the images that comes to mind. And it plays on multiple levels, right? One, it immediately communicates at an enormous scale the fear and the inaccessibility that math symbols can have for so many learners, really whether they're children or adults.
Randy, can you share your screen? We don't have the slides.
You don't have the slides.
They're not up there.
Okay, thanks for letting me know. 1 second.
Yeah, when we come back from breakout rooms, for some reason, you often have to unmute and reshare your slides.
All good. How about now?
That's for everybody.
Yeah.
Oh, that's a scary one. Yeah. Yeah.
There we go. Is that better?
Oh, yeah, that's good.
Okay, good. So you can hear me and you can see the slide. So this was the image I was just speaking to, right? This is an imposing image that unfortunately represents the overwhelming experience that math can present to too many of our learners. It also represents another aspect of the symbol barrier that Keith's going to talk about just in a moment, which is far too often white men are conceived of as those who can do math. And so it's part of the problem that is represented in this image is what we're going to speak about and what we aspire to try to address in our work. Keith?
Okay, so symbols are they go back to the beginning of mathematics with the invention of numbers around 5000 BCE, and it was all to do with marking on clay tablets. Then we've got cuneiform tablets, we've got the Rhind papyrus, and in all of those things you see symbols. And then we've got into the current era. We've got Brahmagupta in India, one of the people that invented the Hindu-Arabic number system, as we call it. Again, it was all symbols. Then we've got Al-Khwarizmi in the bottom left, inventing algebra in Baghdad in the 8th century current era. It was all symbols, symbols, symbols. And it was all about doing mathematics with symbols. When they wrote books, and Al-Khwarizmi wrote the first algebra book, they didn't use symbols in the books. It was written in text, in words, because they were meant for learning. So back in the day, symbols were for doing mathematics, words were used for teaching mathematics. And then in the 13th century, we've got Leonardo of Pisa, producing a great book that brought Hindu-Arabic arithmetic and algebra to the West. Again, it was all written in text for the teaching. So kids learned mathematics through words, but then they had to learn to do mathematics with symbols. But with the printing press, that all changed because it was possible to print symbols on a page. So the printing press was where technology interfered with education. And from the printing press onwards, mathematics textbooks have been filled with symbols, because you could do it with symbols in a text, but you couldn't do it in a handwritten manuscript because it had to be copied by hand. So the fact that we think mathematics has to be learned with symbols is a technological fact because of the printing press. It has nothing to do with innate pedagogy. It was just that there was a technology and people always flock to the new technology. Well, today we have even newer technologies, so we can fix what went wrong in the 15th century, namely that you had to go through symbols to learn mathematics. It never used to be the case. It no longer needs to be the case. That was for 500 years because of the printing press.
I just add to that, Keith, one comment that I know you often make related to the printing press is, it was very good at what it was designed to do, which was transmit mathematics on a page. It wasn't designed to support K-12 learning or instruction.
Right, yeah, yep.
Okay, so what are some of the implications then, Keith, of this?
So then there was this was the study that turned me from being a pure research mathematician with very little interest in education to spending a huge amount of my time looking at education. It was this research in the 1990s that was published in a book called Street Mathematics and School Mathematics, which showed that when you went round, this was a street market in Brazil, but it can happen anywhere in the world. If you look at people, young kids in the original study or adults at supermarkets, whatever it is, people working in dairies and so forth, you find that whatever mathematics they need in their everyday work or life, they very quickly become proficient at it. And in fact, they become so proficient that if you ask them challenging questions in that domain, they'll get them right with 98% accuracy. But if you ask them the same mathematical questions in symbolic representation, it's not 98% correct. The same people drop down to 37%. They can do the mathematics. Everybody can. The symbols get in the way. It really is a barrier. That's why we call it the symbol barrier. The name is mine, but the concept isn't. It goes to the people who wrote that research monograph. Actually, that book is very readable, still available, that book that's listed at the bottom there. And the slides will be available in the package you can get after the days are finished. That's huge. That 98 to 37 shows how big a barrier symbolic representations are to learning mathematics.
That's right. And so when we at BrainQuake think about our work, we're constantly thinking about how can we improve the interface to mathematics, because the difference, as Keith has just explained, it's not small. It's the difference between someone being proficient, confident, and having access to any number of economic or other opportunities, or not, growing up to think, I'm not a math person. And so this idea that we can be quite confident that all children can be proficient, and yet nearly all children experience the symbol barrier, and some children experience the ramifications of the symbol barrier disproportionately to others. So we're going to now go back into the breakout rooms with the second prompt. And so here, the second prompt is asking you to share any of your own experiences around observing the symbol barrier in your practice. And if so, sharing a bit about what you've observed. So we'll take another 3 to 4 minutes, Kara, if you wouldn't mind. And then, as I said before, maybe select a facilitator just to keep an eye on the clock and to help make sure all voices that want to be heard are heard. And then come back in and share any of your observations or notes in the chat.
Okay, I'm opening the breakout rooms now. Okay, if you are still here in the main room, there are a couple things that could have happened. It might be you just joined us. If you'd like to join a breakout discussion group, just type chat to either everyone or to me, Kara Harper, and I'll add you to a breakout group. It could also be, there are sometimes some devices, especially Chromebooks, that sometimes make it difficult to join a breakout room. But if you are unassigned, if you're still here in the main meeting with us and you want to be assigned to a group, just respond in the chat. Okay, I see a couple of people writing. So I'm going to start adding people in. It may take me a second to get to you because I'm getting quite a few requests, which is great. I think I have everyone who put in a request, but if you are still here with us, oh, I see one more. If you are still here with us, it might have been that I missed your message, so feel free to message me again if you're still here with us and want to join a breakout room. Okay. Yeah, so Randy, one note is it does seem like the second time we go back to rooms, I think it's good to keep the same groups, but there are often people who have like joined since I created the rooms, and then it like, there's always a lot more of the chat activity of trying to get into a room, but so far it's all been handleable. I don't know.
No,
I don't know if we were close to that 1,000 participant limit, we might have more problems with it.
right.
Cindy, are you trying to say something? Okay, I'm gonna unmute you. Yeah?
Could I go in a different breakout group? Mine all had other things they were doing.
Yes, you definitely can. Let me check and see if I can find you. Okay. I'm gonna move you to, which one were you in? Were you in one?
I don't remember the number. I'm so sorry.
Okay. No worries, I'll move you to another one. But I might move some other people in that room too.
Okay, thank you.
See if that worked. Huh, Cindy. Yeah, I'm not sure what's happening, Cindy, because I thought I added you to another room. It's possible there are, there are some computers that have a hard time handling the breakout rooms. So were you in one before?
Yes,
Oh, then I'm not exactly sure because I did try to just add you again. I'll see if I can find you. We have a lot of people, and so it can take a little while to find everybody and try to.
Out of curiosity, is there renewal credits for this conference?
Yeah, so I think Scott with Mid School Math, his team is going to try and put together some kind of certificate. And so depending on your district, like how, you know, whether or not you can use those kinds of things, but they can definitely reach out to us as organizers and let us.
They'll accept any certificate that.
Oh, yeah, there will be a certificate.
Okay, great.
Okay, yeah, I'm not exactly sure what happened.
I'm totally enjoying this day. This is good.
Oh, that's so good.
Good.
Claire, why don't we bring folks back?
Okay, we're going to bring everyone back, and during the break, I'll try and figure out, Cindy, what might have happened. But we've got about 60 seconds till when everyone else gets back. But I am going to go ahead and again unmute you. Yeah, just so you know, we're recording this session. Your picture and name won't show up. Your audio might, but I think we're going to try and edit those out. Okay. Okay, so we've got about 40 seconds left. And you'll be able to see when other people come in because it'll be like a stream of participants. Oh, okay.
There we go. Okay, I'm going to go ahead and share my screen. You can still hear me, right? I'm unmuted.
Okay, good.
Okay. Great. So again, hopefully that was a useful and engaging conversation. Go ahead and share anything that struck you one way or the other in the chat if you are so inclined. When we think about how we might break the symbol barrier, we often try to take our inspiration from looking at other interfaces and ideally other math interfaces that have had a disproportionate impact, particularly with, and whenever possible, how people have related to and accessed mathematics. And so we ask ourselves the question, are there any inventions that have significantly democratized mathematics, and what might we learn from them? And our take is, sadly, there aren't that many. However, the abacus, we think, is one of the best examples, and that's true for a couple of reasons. One, the abacus looks like and is often considered to be a children's toy, right? So it conveys and produces this sense in many of us that it's easy, it's simple, it's accessible, it's non-threatening, but that simplicity and toy-like nature really belies an incredible design elegance, because the impact that this tool had on the world's access to mathematics was enormous. Virtually overnight, the abacus allowed the average person in a marketplace to access the ability to manipulate and use arithmetic in ways that previously had been reserved for elite classes, or those who were privileged enough to have access to more formal education. And so for us, we often ask, can we replicate the sense of the goals of the abacus in any meaningful ways ourselves in our work? And so now Keith's going to speak a little bit to one of the ways, or a couple of the ways in which we think we might be able to do that.
Okay, so this is the puzzle. It was the one that we launched ourselves with a few years ago. The game was called Was It Trouble? It's recently been superseded by a new product, although Was It Trouble is still available for Android and the web. This is a gear system. It's actually a non-symbolic representation of systems of four simultaneous equations in four unknowns. The mechanics, and maybe you've had a chance to look at that video we put the URL to earlier on YouTube. You rotate one of those small gears, the 4, the 5, the 6, or the 9. The big wheel then rotates by the appropriate number of clicks. And the goal is to use the 4 cogs to rotate the big gear so as to produce, or so as to turn it so that each one of those items, the keys and the bonus items, passes under and stops momentarily at the 0 at the top when you obtain that thing. So the idea is to collect all of the items and get bonus points and so forth. And what you're doing when you're doing that, you're having fun, and kids of middle school age and upwards have had fun on this for years now. You're actually doing some pretty darn sophisticated mathematics. In fact, even for a puzzle with 2 cogs, let me show you what math. I think we're going to do that in a minute. So
yeah, we are. Let's take a look at the tanks puzzle, which chances are no one has seen this just yet.
Yeah, this is in the new product. It's in the App Store at the moment for the iPad and the iPhone, but it'll come out for everybody in due course. This is to deal with fractions and proportion reasoning. The mechanics here is you take fluid from an input tank, and here it's got 64 units in it, and using a valve of different shapes, circular shapes, fractions, percentages of various different shapes. You have to move the yellow arm, in this case horizontally, into different proportions so that you can fill those 2 tanks on the right exactly without any overflowing. You may be able to do it in 1 move. It may need 2 fills. It may need 2 fills with moving the gear in the middle, in between them. So the complexity of the puzzle can go up to make it a more fascinating game, but it's all about fractions and proportions using very different representations, both decimals, fractions, as you can see here, percentages, some just geometric, where you go by quartiles of a circle and so forth. So all of the familiar ways to think about fractions are in there, and you mechanically, interactively have to divide input amounts into output amounts. And the output tanks, there are as many as 4 output tanks. So the complexity goes up, which makes it a more fun game, but underneath it, it's reasoning about fractions and proportions in an interactive way. And for both the gears game and the tanks game, the mathematics that's involved is really pretty sophisticated. This is the symbol barrier writ large, if you like. Those are exactly the same problem. It's a 3-part problem. In one, it's textbook words. Solve the system of equations. On the left, it's game. Collect the keys to free the wizards. Do it for bonus points. Do it for honor points. Do it for maximum stars. Do it for... So it's the same pedagogy. It's the same mathematics. And literally, it's the same mathematics. That puzzle does not solve the equations for you. You solve the puzzle. When you solve that puzzle, your actions, step by step, are what you see on the right-hand side. You go through, if you didn't have the puzzle and you wanted to do it with a paper and pencil, you'd have to start writing down those systems of equations. Don't worry about the mod 65. That's just because it's a clock arithmetic. We had to have something on a screen, so we went up to 65. That's just an artifact of the puzzle design, but it's all about solving systems of equations. Most of us would think that the stuff on the right is college level mathematics. And when we present it with symbols, it has to be college level because you need to be really proficient with the symbols. But the mathematics on the left is exactly the mathematics on the right. The symbols have been separated from the mathematics, which means kids can learn how to solve equations before they learn the symbols. Earlier on this morning, I talked about learning a musical instrument and then learning to read music. It's the same thing. Learn to solve equations on an instrument on the left. Then, if you want to and need to, you can learn you can master the language, which you will need if you want to go on into STEM. We're not saying symbols are not important, but they should not get in the way of learning. This separates the learning from the learning of the mathematics from the learning of the language. Separate the two, a difficult problem becomes 2 separate problems.
Yeah, and I think also just to quickly add to that, it's important to note that there is no single right answer to this particular puzzle. There are, in fact, billions of solution paths that might ultimately produce success. And the implication is, of course, that allows learners to make sense of this problem space in their way, right? Not necessarily in the way that I would or you would, but in their way. And that kind of liberation allows for children to engage with mathematics, adults to engage with mathematics in wholly new ways, and powerful and proven ways. So Keith, maybe you can speak a little bit to one of the research studies that's been conducted on our work.
Yeah, the first study that came out was actually conducted by Jo Bowler and a couple of her graduate students. The one that ended up writing her dissertation on it, her PhD at Stanford, was Holly Pope, who's now teaching somewhere in the Midwest. I think she was at University of Hawaii for a while as a postdoc. But this was Jo Bowler. Jo Bowler spent a lot of her career in the UK designing assessments. And she designed this assessment in order to look at things like, was it trouble? The 5 questions are interesting, that questions 1, 2, 3, and 5 are the kind of questions you would normally get on a multiple choice type question or a fill in the blanks question there. They were to do with the kind of arithmetic that was done with that gears puzzle, with was it trouble? And the idea was they had a pre-test and a post-test like this, and in the middle, one group of students, and taught by the same teacher, one group of students were given Was It Trouble to play, the Gears puzzle, for 10 minutes a day at the end of class, 3 times a week for a month. So a total of just 2 hours spread over a month playing Was It Trouble. They had the pre-test and the post-test. At the end, on the post-test, students in both groups got roughly the same results for questions 1, 2, 3, and 5. The people who played Was It Trouble did about 2% better overall. Well, that's not significant. What was huge was question 4, which is an open-ended question where you can't use a cookie cutter approach. You've got to think about it. The average gain from the kids who played Was It Trouble for just 2 hours was 16.4%. Their performance was enormously better and they enjoyed what they were doing. The feedback was positive. So simply playing that game for 120 minutes over a month produced a significant difference, almost a 20% difference in performance from playing that to doing something else in class. So that was such a validation that I approached a colleague in Finland. Finland has a lot of academics that study games and things. Rovio and Angry Birds have made games very big in Finland. They did some studies very similar to that. One study was dramatic. It showed that if you give kids a fraction game as a pre-test and a fraction game as a post-test, kids who play Was It Trouble as an intervention do better at fractions arithmetic. Even though Was It Trouble is whole numbers arithmetic, if you remove the symbol barrier by presenting fractions in a game and arithmetic in a game, in the case of our game, kids who play the fraction, kids who play the Was It Trouble integer game, the whole number game, their fractions arithmetic improves too. So when you separate symbols from the thinking, you get transfer, you get dramatic improvements. Most of the problems is that symbolic language. Take away the symbols, kids can do it and they do it quickly. Just 2 hours over a month is all it takes.
Yeah, and so again, I just want to underscore that while we're using some of our work to help to illustrate the notion of the symbol barrier and the opportunity of the symbol barrier, the main point is sharing this idea with you and hopefully inspiring you as a math practitioner community to be thinking for the first time, continuing to do this work if you've already been dealing with the symbol barrier, to continue to uncover ways to address this issue, that hopefully we're impressing upon you how fundamentally really oppressive the symbol barrier is, and that it is possible to overcome it. Right? And so some of the impacts that we observe to even moderate success in addressing the symbol barrier includes these items. And the very first bullet is an area that we are really pouring a lot of energy into right now, because as you may surmise, the implications of breaking the symbol barrier are that I mean as a whole community, not just BrainQuake, we would be in a position to far more equitably assess children's true math proficiency. So we would contend that generally speaking, the types of measurements that we provide to children today, we as a community again, are fundamentally, significantly misrepresenting children's math proficiency, certainly their math potential. And as a result, we are sending messages that lead to populations that grow up saying things like, I'm not a math person. Right? So we think this is one of the most important places where we can all focus in terms of trying to improve our collective practice. I'll speak real quickly to persistence as well, because that came up in Keith's keynote. When you break the symbol barrier, one of the things that naturally happens is a desire to continue trying to solve the problem or to continue to engage with the problem space. It's no longer about making sense of decontextualized symbols. It's about the natural love of learning, right? And so that can sometimes be an indicator of whether or not some of your own experiments approach breaking the symbol barrier. You start to see a transformation in the way in which children engage with the content. So as I said at the very start, right in this moment, we don't have an optimized for you, that is for schools, product to make available. That is coming, and we'll be happy to keep you apprised of that. But in the interim, it struck us that while we don't have something like our full suite of puzzles to offer you right now, that in the name of trying to provide low to no tech strategies, there might actually be some ways that some of you, if you were so inclined, could use our work. And we'll put these screenshots into the shared folder that you'll have access to following the conference. And so on the right, what you're seeing are just some screenshots of the different types of gears or was it trouble puzzles that are available or that can be created, which is to say that the puzzles can include 1 gear, 2 gears, 3 gears. In the middle screenshot, that wooden gear is indicating a gear that can only be used once. And so there are ways to insert variables into the gears themselves. And so while the technology may not be available, providing children with screenshots and asking them, for example, to write down the moves that they would make in order to perhaps capture just one of the keys. We don't need to necessarily require trying to solve the entirety of a puzzle on paper. That might be a low to no tech way to use some of our work. You might also prompt your students to design their own was it trouble puzzle, where perhaps they come up with the gears and the value of the small gears that they want to use, and they think about where they would place keys on the large gear. Right? And that's something that they could share. And the value of getting that right or wrong, I think is absolute, right? Simply having children talk through the design choices they made would be incredibly valuable. You might prompt kids to use common household items to build a version of the was it trouble puzzle. A little bit of tracing paper and some cardboard might go a very long way and could spur all sorts of interesting discussion around what that design process was like. We mentioned that these puzzles admit oftentimes billions of different solution paths, prompting children to write down 2 different ways in which they might move a key to the fixed pointer would also be an exercise in problem solving and critical thinking. And then if there is access to some tech, for any of the above, having a child record a short video and sharing that with the class, and maybe then sharing a little bit about the thinking and that went into that, and perhaps some of the challenges and successes that were experienced might also be an accessible way to leverage some of the work that we've done. And so again, we'll provide you with some screenshots and hopefully you can make some good use of those. So I think we've got just enough time to go into a last breakout room. We might run a minute or 2 over, but here's the third prompt. Having spent the last 45 minutes talking about the symbol barrier, we'd love for you to now share any of your questions or thoughts around how you might be able to break the symbol barrier. And then upon return, just like you've done previously, feel free to share any of your thoughts or your insights in the chat, and then we'll be able to wrap up. So Kara, I think we're good to go.
Yeah, I'm going to open all the rooms. I did assign everyone who was in Breakout Room 5 to a different group because there was some concern about that group, not enough participation. So you'll all be in different groups. And then if you are finding that about your room, please come back to the main room and I'll do my best to assign you to a different group. Okay. Okay, I think everyone has been assigned to a room. If you are still here in the main room with me, it may be that you joined our meeting late, and if you would like to be assigned to a room, just reach out in the chat, either to me, Kara Carpenter, or to the whole group, just saying, hi, I'd like to go to a breakout room, and I will add you to one. Okay, I see a few coming in, and so I will add folks to groups as soon as I can. Okay. A few more. Okay.
Kara,
Yes.
if we wanted to offer to just hang out during the break to answer questions, if folks have questions, is that okay?
Yeah, I think that's fine.
Okay.
Should I close the rooms or should we give people a little bit more?
Let's give them just maybe another 90 seconds or so.
Okay, great. And then, yeah, I think that's fine. I may have the slide up for the
Sure.
next presentation, just for
Of
people
course.
who are expecting to see that
Of
or want
course.
to know what's next.
Yeah, of course.
Okay, should I bring folks back now?
Sure, sure.
Okay. So they'll all come back in about 5 minutes now.
Yep. All right. So welcome back from that last breakout room. As always, feel free to share anything that struck you in the chat. We're going to wrap up. Thank you all so much for taking time out of your day to be with us. We are humbled by your presence and your work, and would really love to just honor you with respect to everything that you're doing for children right now. Kara has let us know that we can hang around during the break between this session and the next session. So if folks would like to ask questions in the chat, maybe we can even talk to each other. Keith and I will stay here, and we're happy to do our best to provide you with answers. And again, thank you so much for being here. We hope you enjoy the rest of the day.
Okay, yeah. We probably still have audio link. I don't know.
Yeah.
Okay, so we still have audio, and we've got the chat going. Right.
Okay, and then I'm trying to figure out how I can get the next slide up.
Yeah.
So at 2 o'clock, we're going to have, Barbara's talk, and that'll be in about 10 minutes. So I'll switch this to 10.
So Keith, there's a question in the chat about, is this about textbooks? Do teachers need work like BrainQuake to move away from just symbolic teaching?
Ha! Oh boy, there's a complicated question with all sorts of ramifications. We're not in the business of trying to replace anything, teachers, textbooks, classrooms, or anything. It's supplementary material. We've done lots and lots of, as everyone who's been involved in SBIR does, we've had research done throughout the development process, both peer-reviewed research and internal research. So there's been lots of research. We're working on this. We've certainly worked in classrooms. We've adopted the principle of let's see what the teachers do with the material to a large extent, and then learn from the teachers. And the teachers have used this both in our testing and from feedback we've had anecdotally from teachers who've used it with classes, is they use it in many, many different ways. Any way that you could think of, I think teachers have tried it. We tried to be totally agnostic to how it's used. It provides a way of breaking the symbol by. They're instruments on which you can learn to play certain kinds of mathematics without having to learn the symbolic language first. And as with a musical instrument, the teachers can use it in many different ways. They can develop classes around it. They can let it assign them for homework. They can do it lots of different ways. They can split a class into two. One class runs on the games, the other one does all sorts of other stuff. And we've been learning from the teachers as to the ways that they can use that. And it's really up to them in that sense. It's an instrument on which you can play these mathematical problems, if you like. And then you do with that as you will.
We've got a bunch of questions here. Let's see. Another question is, what would we recommend to be done at the earliest stages of emergent learners to teach mathematics as a language rather than procedural-based methods?
Did you want? Are you asking? You want me to answer that one?
Well, you can take a crack at it, or we can co-construct an answer.
Yeah, I was hoping somebody else might jump in with an answer. We've got a whole bunch of expert teachers sitting out there.
So I guess I can start with a little bit of an observation. You know, certainly in the work that I've done in co-founding the public Montessori school, I think what we see is Montessori adopting a very symbol barrier breaking approach that allows children to engage with concepts through concrete manipulatives that once understood and once viewed as non-threatening, provide for a very fertile field on which to then seed or sprout the symbols themselves. And so in our work, that's a core concept. Is it's not that we think the symbols don't matter or are problematic, but we do think they're not necessarily a very good place to start. But once the concepts are in place and once the fear is removed, then introducing the symbols becomes a very different conversation because they make a lot more sense to children more immediately.
Yeah, so I just responded in chat to someone who said, is there any idea that, do we think that this kind of approach would be used at university level? My answer is probably not, because I think it's, you know, sooner or later, if you want to go on in mathematics to the university level, in engineering or whatever, you do need to master those symbols. The benefit of our approach is you don't need to use the symbols to learn the basic mathematical thinking at the beginning, but eventually you will need to do them. And in some sense, the sooner the better. And I would have thought that by university stage, you probably do need to be doing it in terms of symbols. That's not going to go away. It's an absolutely essential part of doing mathematics. Even throughout history, when textbooks were written in words, which meant there was no symbol barrier back before the printing press, mathematics was still all done in symbols. You do need symbols to do it professionally. But in terms of learning, you don't. And it's learning that we're dealing with. That's where kids get put off mathematics, as Randy just alluded to. If when you meet the symbols, you have already learned how to think in a mathematical way, then you've got through one of the two difficult steps. And the other one is linguistic. Just like if you've learned to play the piano or a guitar by fooling around with it, when it comes to learning the notation, you can use your knowledge of that instrument to help you learn the notation. And the same is true of mathematics.
There's some comments in the chat that I think are particularly interesting around what is and is not getting taught in teacher preparation programs. And so without wading too deeply into what might be political waters, I think it does prompt another one of our design principles that's related to the symbol barrier in general, which is it ought to be agnostic to one's pedagogy. That is to say, there isn't, for example, a 500-page BrainQuake manual on how to teach using BrainQuake's materials. Because in the same way that the work is natural for the children, it's also that way for the adults too. And so we leave it very, very open to interpretation. And so while, for example, we might say, presenting it on an overhead and doing a sage on the stage lecture to a whole class might not be our preferred way of doing it, we would never dare to say to a teacher, don't do that. And there are any number of other ways in which teachers can and have, and families can and have used the work. And so that opportunity to make sense of the materials in ways that most respond to your own expertise is really important to us.
Yeah.
There's another question in here, Keith, about assessments. There's one particularly referencing how would we move this to kids taking the SAT or ACT? You want to dream a little bit there?
We have assessment built into our game right from the beginning because there's an adaptive engine, not in the original Was It Trouble, but the one that's just been released. That has an adaptive engine that delivers puzzles at the right level of difficulty and challenge. And so we are now assessing students all the time. There's no personal identification information involved, but we are assessing the students. The assessment results are there. We are in the process of working with some very experienced assessment scholars to validate our assessments as for possible use in systemic assessment. The potential is absolutely there. We would need to validate it. The irony is, to my mind, we are assessing much better and in a much less stressful environment than the big state tests that involve the systemic tests. I think we are actually getting better assessments than you get from the system, but in order to be able to do that publicly, we will have to validate against those assessments. I think when we've done that, we'll eat their lunch, because I think we get better assessments. But at the moment, we're in the process of doing research, starting research, to validate our assessments in terms of existing assessments.
So I think we should stop there and make sure that Barbara has time to start speaking up if she's so inclined, or get prepared. Again, thank you all so much for your engagement, your questions, your challenges. We really appreciate it, and look forward to seeing you over the course of the rest of the day.
Bye all.
Thanks, guys. That was amazing. All of these have been amazing. It's just such a renewing day to hear such great ideas and to be in a session with so many people that will say something brilliant, and then you'll be like, yeah.